Good morning, welcome to new lecture. Today I will review several examples. There is support on this wall, and this support is subjected to two different forces. So there are two forces acted on this support. The magnitude of the first force, it is F, and the orientation with the horizontal direction is theta. Second force, magnitude, it is 900 pound, and the orientation, it is 60 degree. So there are two forces, both of them, they are acting on this support, and we attach the support to the wall. So the magnitude of the first force, it is F, unknown, and the direction with horizontal direction, it is theta, and again it is unknown. Second force, the magnitude, it is 900 pound, and orientation, it is 60 degree. We know that. Problem statement says, determine the magnitude of F and theta so that the resultant force, it is, the magnitude of the resultant force, it is 1200 pound, and it is directed along x-axis. It means it is in this direction. So, first force magnitude, it is unknown. Direction of the first force, it is unknown, theta. Second force magnitude is 900. Direction with vertical direction, it is 60 degree. We know the resultant force for these two forces, it is 1200 pound, and the direction of the resultant force, it is in the horizontal direction. Let's see how we can find F and theta. We can use triangle law, we can use parallelogram law, or we can decompose in the x and y direction and find in that way. But I use graphical method, and I will follow, for example, for this example, triangle rule. So first I will draw force F, direction is theta. Then I will show the second force, 900 pound. And if this is 60, here, if the horizontal and vertical direction, they are perpendicular to each other, so this is 90 degree, because the summation of all angles in one triangle, it is 180 degree, so this angle will be 30 degree. So this force magnitude will be 900 pound, and with horizontal direction this angle will be 30 degree. So this is theta, we don't know, the magnitude is F, this is 900, and the orientation with horizontal direction, it is 30 degree. And this is our resultant force. The resultant force magnitude is given 1200 pound, and it is in horizontal direction. This is our triangle. So in this triangle we can find F. We know F is equal to square root of 900 squared plus 1200 squared minus 2 times 900 times 1200 times cosine of angle between these, it is cosine 30. So from here we can find the magnitude of F. The magnitude of F will be 616 pound. So we found the magnitude of this force, it is 616 pound. Now if we use the law of sines, we can find the theta. The theta will be 900 divided by sine theta should be equal to 616 divided by sine 30. 900 divided by sine theta is equal to 616 divided by sine 30. From here we can find theta. theta will be equal to 46.9 degrees. So, using triangle rule, I found the magnitude of the F and the orientation of the F respect to the horizontal direction. Let's look at to the next example. Next example, again it is similar problem. There is support on the wall and two forces acted on that support. So again we have wall. Assume we have a screw here or any kind of support. Two forces. One of them it is F1 and the magnitude is given, it is 400 pounds. Another force it is F2. Magnitude it is 600 pounds. This angle between two forces it is theta. So two forces acted on the support here. We know the magnitude of F1, we know the magnitude of F2. We want to find theta, the angle between two forces, so that the resultant force magnitude is equal to 800 pounds. So we want to find theta, the angle between these two forces, in a way the resultant force is equal to the 800 pounds. So find the magnitude of theta, the angle between two forces, so that the resultant force magnitude is equal to 800 pounds. Again, you can use triangle rule or parallelogram law. For this example, I will follow parallelogram law. So this is F1, it is equal to 400 pounds. F2 is equal to 600 pounds. This angle is theta. So from the head of this, I will draw one line parallel to the F1. From the head of this, I will draw another line parallel to the F2 and I will make one parallelogram. Then I will attach origin O to this point, for example point A, intersection point. OA will be our resultant force FR. The resultant force magnitude is given. The resultant force magnitude, it is 800 pounds. Now, in this parallelogram, if this angle is theta, this angle will be theta as well. So, these two angles in parallelogram, they should be equal, and these two angles, they will be equal, and each one will be 180 minus theta, 180 minus theta, because in parallelogram, the summation of all angles should be equal to 360 degrees. Now, if we add all these angles, you will get 360 degree theta plus 180 minus theta plus 180 minus theta. The answer will be 360 degrees. So let's look at to this parallelogram. Now the half side, it is similar to one triangle. So I can write 800 from law of cosines. 800 is equal to square root of 400 squared plus 600 squared minus 2 times 400 times 600 times cosine 180 minus theta. From here I can write 800 squared is equal to 400 squared plus 600 squared minus 2 times 400 times 600 times cosine 180 minus theta. Now we can find theta. If you calculate theta from here, you will find theta is equal to 75.5 degree. So in this example, if these forces, the magnitude is 400 and 600, and the angle between these forces, it is 75.5 degree. In that case, the resultant force magnitude will be 800 pounds. Next example. Next example, again, wall, there is support on this wall, force F1, magnitude it is 30 pounds, force F2, magnitude it is 40 pounds, this angle is theta, we don't know what is the theta. This angle is phi, again we don't know the magnitude of phi, but we know the resultant force magnitude is equal to 60 pounds, and resultant force, it is in the positive direction of the x-axis. So the resultant force, it is in this direction. We want to find theta and phi. So again, we can use parallelogram law or triangle rule. Let's use triangle rule. Resultant force, it is 60 because F1, I draw in order. F1, it is 30 pounds. F2, 40 pounds. This angle, it is theta. This angle, it is phi. And the magnitude of resultant force, it is 60 pounds. So we will use the law of cosine. I can write using law of cosine. 40 squared is equal to 30 squared plus 60 squared minus 2 times 30 times 60 times cosine theta. So in this triangle, if we write law of cosine, we know 40 squared is equal to 30 squared plus 60 squared minus 2 times 30 times 60 times cosine of angle between these forces. From there you can find theta. Theta will be 36.3 degree. In similar way, you can use the law of cosine and you can find the phi. So we can write again 30 squared is equal to 40 squared plus 60 squared minus 2 times 40 times 60 times cosine phi. From here, in this triangle, law of cosine, 30 squared is equal to 40 squared plus 60 squared minus 2 times 40 times 60 times cosine phi. From here, you can find phi is equal to 26.4 degree. So, 3 examples I solved. There are 2 examples. I will explain the statement of these problems today, but you will think about that, you will try to do it yourself. So you will solve yourself, regardless your solution is right or wrong. Next session, in the end of the session, I will solve this problem. First, the right policy, the good policy in order to learn these fundamental engineering courses. You should solve a lot of problems, but how you will solve the problems? You will read the problem statement first. You will try to understand, to digest the problem statement. You can think for hours. Then regardless, you know the solution or you don't know, you will solve it. You will solve problem. Maybe your solution is right, maybe it is wrong, no problem. Then you will look at to my solution, you will figure out right solution. If your solution is right, you will review it. If your solution is wrong, 2 more times, solve it. Try to understand, try to digest the concept. In that case, you will learn the problem. Let's look at the first problem statement. There is a support. This support, it is on ground level, like this, horizontal support. This support is subjected to 3 different forces. One of them in horizontal direction, the magnitude, it is 6 kilonewton. Another in vertical direction, magnitude, it is 8 kilonewton. Another, it is inclined force, F, magnitude, it is F, and angle between this force and horizontal direction, theta, is equal to 30 degrees. Problem statement says, determine the magnitude of force F. Determine the magnitude of force F so that the resultant force of 3 forces is as small as possible. So we want to find the magnitude of F in a way to make the resultant force for these 3 forces is as small as possible. It means we will make the resultant force minimum. We will minimize the resultant force. In which direction? If we apply this force, the resultant force for these 3 forces is minimum. What is this force magnitude and what is the resultant force magnitude? So maybe I made mistake, I will explain one more time. We have support. This support is subjected to 3 different forces. Horizontal direction 6 kilonewton, vertical direction 8 kilonewton, inclined force in the direction of 30 degrees with horizontal direction. The magnitude of this force is unknown. The magnitude of this force is unknown. We want to find the magnitude of this force in a way to make the resultant force minimum. So we will minimize the resultant force magnitude. We will find this force magnitude, it is unknown. After finding this force magnitude, we will find the minimum resultant force magnitude. So there are 2 unknowns. First, we will find the minimum magnitude for this force. Then we will find the minimum resultant force. I will read problem statement one more time. Determine the magnitude of force F so that the resultant force Fr of the 3 forces is as small as possible. What is the minimum magnitude of resultant force? So you will think about this problem. Then next problem. Again, we have support here. Assume this is ground level. We have one plate. We weld it to another plate, and this plate, it is like base plate. Base plate we use under column. It is subjected to 1, 2, 3, 4 forces. So the force magnitude, I show the magnitude and direction. F1 magnitude, it is 8 kilonewton. Direction, it is in this direction. Angle, it is given by a small triangle. In horizontal direction, the length is 3. In vertical direction, in the horizontal direction, the length is 4. In the vertical direction, it is 3. And this is 5. So we have this place. This is base plate, for example. This is gusset plate. And this gusset plate is subjected to 4 different forces. The first force magnitude, it is 8 kilonewton. It is in this direction. And the angle, horizontal 4, vertical is 3. Another force, F2, magnitude 6 kilonewton. You see the direction of sense of vector, and this triangle, in vertical direction it is 4, horizontal direction is 3, so this will be 5. Another force, F3, in the horizontal direction, the magnitude it is 4 kilonewton, and you see the direction of the force. Another force, F4, magnitude it is 6 kilonewton, and the direction again, you see the direction. So, in this force system, we want to find the resultant force. What is the resultant force for these 3 forces? Try to think about these problems. Of course, again, I will solve these problems in the end of next lecture, but try to solve yourself and think about that. Thank you so much for watching this lecture. See you next session. Bye bye.